Okay, so today we're going to start working on factoring out greatest common factors. Greatest common factors. So given a monomial or a binomial or trinomial, we are going to be looking for the numbers and the variables that they have in common. And when we do that, what we're looking for is the greatest common factor, and we're going to be technically undistributing. We're actually going to be pulling something out or dividing out a monomial. So let's start by finding the greatest common factors of 16 and 14. So first of all, who remembers what a greatest common factor is? Okay, so GCF stands for greatest common factor. Okay, and to be able to find those, we need to know the numbers that multiply to get the numbers we have. So let me go ahead and pull up our factor generating calculator. And we're going to start with the factors of 16. And some of you can probably list these without having to use a calculator. So factors of 16, numbers that multiply to get 16, 1 and 16, 2 and 8, if I look over here, and 4 and 4. So those are all the numbers that equal 16. How about 24? Well, 24, I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So what I'm looking for when I'm looking for the greatest common factor, this means I'm looking for the biggest one that is the same. Okay, so I see they both have 1s, they both have 2s, they both have 4s, and they both have 8s. So which one of those is the biggest number? Yeah, it's the 8. It's the 8. So the greatest common factor between 16 and 24 is the 8. They have multiple numbers in common, but the 8 is the one we're looking for. Okay, so now let's take a look at what happens when we have two monomials. Okay, two monomials. So we have 16 and we have 24. So we're going to go ahead and instead of using our 8, we're going to start by thinking about numbers that divide into 16 and 24, okay? And we're going to pull them out. So we're going to divide. So let's start with 16 and 24. Well, they're both even numbers. So the first thing I can do is divide by 2. 16 divided by 2 is going to give me 8. 24 divided by 2 is going to give me 12. So far I've pulled out a 2. So other numbers that we might want to use are 2, 3, 5, and 7. So those are the most common numbers that we look for. Sometimes there's some bigger numbers, and if we can find those bigger numbers early, that means we can get there faster. But I want to check and think about 8 and 12 again. Well, they're both still even. Okay, so that means I can take out another 2. So 8 divided by 2 is 4, 12 divided by 2 is 6. And I can do another one. So divide by 2, that's a 2. 6 divided by 2 is 3. So 2 and 3, I'm done. That's not going to go any farther. So now I have just my letters left. Okay, so I'm going to start by taking a look at my x's. I have 2 x's and I have 1 x. Well, how many x's do they have in common? They have 1 x in common. So I can actually take it and pull it out. And I'm going to go ahead and cross out what I took out. So this one still has 1 x left. And this one doesn't have any x's left because I took it out. Now let's look at the y's. 1, 2, 3 y's because this is y cubed and 2 y's here. So how many y's can I take out of this one? Well, if I take 1 out, I see I can probably take another one out. Now there's no more y's on this side, so that means I can't take any more out. So this piece right here, this part is my GCF, okay? And to be able to come up with what that answer is, I need to multiply. So 2 times 2 is 4, times 2 is 8, which we know that's the number they had in common. And I have 1 x and 2 y's. So the GCF is 8xy squared. So that is what they had in common, an 8 an x, and a y squared. Okay, so now let's move on to how can we put this into binomials, trinomials, and kind of move this process. So what we're actually doing is we know that when we distribute, we multiply. 2 times 3 gives me 6, and 2 times 4 gives me 8. So this time I'm going to give you this, and we need to come up with this, okay? So let's think about what number I can take out of 12 and 8. 2, 3, 4, 5, 6, any of those numbers work? I know I can take out a 2. Can I take out anything bigger than a 2? What about a 3? What about a 4? I can't take a 4 out. How about a 5? What about a 6? Yeah, I can take a 6 out. So if I divide by 6, 12 divided by 6 is 2. 18 divided by 6 is a positive 3. So the GCF in factored form is a 6 and a 2x plus 3. So I factored out that 6. Okay, so that's where we're heading, is to undistributing. All right, so now let's take a look at our first binomial. So 12a squared plus 16a. And here's the numbers we're going to use, 2, 3, 4, 5, 7. 2, 3, 4, 5, 7. If we focus on those numbers, we ought to be able to eventually get to our GCF, okay? So we're going to start with 12 and 16. Well, what number goes into 12 and 16? Well, the first one I know that can go into 12 and 16 is 2. So 12 divided by 2 is a 6. 16 divided by 2, that's an 8. Can I divide again by 2? Yeah, I can divide again. So 6 divided by 2, that's a 4. 8 divided by 2, whoops, let's try that again. 6 divided by 2 is 3, and 8 divided by 2 is 4. So I'm now down to a 3 and a 4. I know that there's no factors in common between 3 and 4 because 3 is prime. So I'm done with my numbers. So how many A's do I have? I have 2 A's in this column and I have 1 A in this column. So when I factor out the GCF, I see that I can take 1 A out. And I went ahead and I crossed out the A that I took. Now there's nothing else left. Okay, there's nothing here for me to take. So to be able to get my GCF, remember this is multiplication. So 2 times 2 is 4, and I have 1A. So my 4A is what's on the outside. Well, what's left in each of these boxes? Well, here, that's a 3A. And here, that's a 4. Well, is that a positive 4 or is that a negative 4? Well, there was a plus sign here, so that's a positive 4. So what's left is 3A plus 4. So my factored form is my GCF of a 4A with a 3A plus 4 on the outside. Okay, let's try another one. We have 18, 12, and 9. And we have lots of variables here, C's and D's. Okay, so let's start by, can we divide by 2? No. Can we divide by 3? Yeah, we can divide by 3. So we're going to start by putting a 3 on the outside. 18 divided by 3 is 6. 12 divided by 3 is 4. 9 divided by 3 is 3. Now, what I need to realize is that 3 is prime. And since 3 is a prime number, which means it has no other factors other than 1 in itself, I'm done. I cannot take out any more numbers at this point. So now I'm going to go ahead and write my C's. Well, how many C's do they have in common? Let's start by taking out 1. If I take out 1 C, I can cross out a C in every single one. Can I take out any more C's? No, I can't because there's no C's left in these two. So I'm done. I took out 1 C. Let's look at our D's. There's 2 D's here, 1 D here, 1 D here. And if I take 1 D out, cross them out, I see that I don't have any more D's I can take. So here is my GCF. Again, if I multiply those, 3CD, that's going to go on the outside. Well, what's left here? So here I have a 6 and a D. Here I have a 4 and a C, and here I have a 3. Well, I kind of need some signs. So what kind of 4 is this one? Well, it's a positive 4, and this is a positive 3. So what's left in my parentheses is 3CD, parentheses 6D plus 4C plus 3. Okay, let's try another one. Remember, the numbers we're looking for, 2, 3, 4, 5, 7. So 3, 9, and 36. Go ahead and hit pause. See what you can do with this one. Okay, so let's start with taking out a 3. So 3 divided by 3 is 1. And -9, don't lose your sign. -9 divided by 3 is a -3, and 36 divided by 3 is 12. Well, I'm done because 1 is prime, 3 is prime. I can't go any further. Even though 3 goes into 12, I cannot factor out a 3 from a 1. All right, so I'm going to go ahead and write my P's, and I'm going to go ahead and write my Q's out, and we're going to start pulling them out. So how many P's can I take out? Well, I see that I can take out 1. If I cross them out, they're all gone. I see that I can take Q, and then I don't have any left. So there's no more Q's that I can take out. So my GCF is 3PQ. And what do I have left? Well, here's a 1P, and here's a -3Q, and then what's left over here is a positive 12. And I'm done. Okay, so here's 3 more. Go ahead and hit pause, see what you can do with these. Remember, you're looking at the numbers 2, 3, 4, 5, 7. Those are the numbers you want to think about with division. Okay, so let's start with this first one. So I know that I see a 7. So that would make me think I can divide by 7. So 7 divided by 7 is 1. 49 divided by 7, that's a positive 7. I'm going to go ahead and write my positive in there. And I have my x there. I don't see that I can take anything else out. So my answer is 7, the 1x plus 7, or 7x plus 7. What about this next one? Well, I have a 5 and a 15. Well, I see 5, so I know I can take out a 5. 5 divided by 5 is 1. -15 divided by 5, that's a -3. Make sure you don't lose your signs. And here's an a squared, which means I have 2 a's, but I don't have any a's here. So my GCF is 5, and I'm left with a 1a squared minus 3, because this is not going to change. I could also have 5a squared minus 3. Those are the same thing. All right, see what you can do with the next one. Let's take out a 4. 4 divided by 4 is 1. Positive 16 divided by 4, that's a positive 4. Positive 12 divided by 4, that's a positive 3. And I'm going to go ahead and write out my A's and my B's so I can go ahead and move on to factoring those out. So I see that they all have an A, so I'm going to take out an A. And I really would like to take out a B, but I don't see any B's here, so I cannot take out any B's. So my GCF is my 4A. And what do I have left in the first box? So I have a 1AB squared, 1AB squared. The second one, positive 4 and 1B. And in the last one, it's just a positive 3. I don't have any other letters left, any other variables left in that last spot. Okay, go ahead and make some progress on today's homework, and we'll catch up with you tomorrow as we practice some of the same thing.